student, welcome back to our physics class. Last day we started the chapter magnetism. Today we will read the same chapter magnetism. Last day what we learned? We learned magnetic and non-magnetic substance. What is the magnetism? Natural and artificial magnets. Properties of the magnets. In the properties of the magnets, attractive property, magnetic force, magnetic field, and the two poles of the magnets, south pole and north pole of the magnets. Also we learned the discovery of magnets. Up to this we learned last day. Now today we learn the directive property. Before that we see that once what is the magnetic compass. A magnetic compass is a simple device that used the directive property of a magnet. It consists of a small flat magnetic needle balanced on a nearly frictionless pivot. The north pole of the needle is marked with red color. It is then enclosed in a flat aluminum case with a glass cover. Directions such as north, capital N, northeast, capital NE, east, capital E, southeast, capital S and E, south, S, capital S, southwest, capital S and W, west, W, capital W, and northwest, capital N and W are marked at the base. The magnetic needle is free to rotate about its center and always points in the north-south direction. It is primarily used for navigation. So what is the directive property of a magnet? Mark it. A freely suspended magnet always points in the geographical north-south direction. This is the directive property of a magnet. This is known as the directive property of a magnet. So what is the directive property of a magnet? A freely suspended magnet always points in the geographical north-south direction. This is known as directive property of magnets. The pole of a magnet pointing towards the geographical north is called the north-seeking pole or north pole of the magnet. Mark it. The pole of the magnet pointing towards the geographical north is called the north-seeking pole or north pole of the magnet. The pole of the magnet pointing towards the geographical south is called the south-seeking pole or the south pole of the magnet. Every magnet, irrespective of its shape, has a north pole and south pole. We cannot separate the pole of the magnet. If we break the magnet, then also it gives us two poles, north and south pole. So it's not depends on the shape, size of the magnet. Always pole exist in pairs. We will read this property also. Now activity. To verify that magnets always point in the north-south direction. What material we required? A bar magnet, some thread and a stand. Suspend the magnet from the stand by the thread tied to the middle of the magnet. Allow the magnet to come to rest in the base of the stand. Mark a chalk line along the length of the magnet to show its resting position. Now disturb the magnet slightly. Allow it to come to rest. What you will observe? You will see that the magnet comes to rest in the direction marked by you. You can find that the direction is north-south. A freely suspended magnet always points in the north-south direction. This is the directive property of the magnet. Magnetic pole exist in pairs. Just before few minutes I told you, that is, the magnetic poles always exist in pairs. Magnetic poles always exist in pairs. In other words, magnetic poles cannot exist independently. We cannot separate the poles of the magnet. Always it comes in pairs. If a bar magnet is broken into two or more pieces, such each of them will have a north pole and a south pole. It is impossible to obtain a piece of magnet with only one magnetic pole. It is impossible, totally impossible. Hence we say the magnetic poles always exist in pairs. Now attraction and repulsion. Let us now find out how a magnet behaves with another magnet. Activity. To find out how the poles of two magnets behave when brought close together, metal requires two bar magnets with marked poles, a stand and some thread. Step 1. Suspend one of the bar magnets from the stand and the help of the thread bring the south pole of the another bar magnet near the north pole of freely suspended bar magnet. What we will observe? There will be the attraction between two magnets. When a south pole comes near the north pole of the another magnet, it attracts each other. Next step, we bring the south pole of one magnet to the south pole of the another magnet. It repel each other. Now we bring one north pole of a magnet, another north pole of a magnet, then also it's repel each other. Now the suspended magnet's north pole, we bring the another bar magnet's south pole, it attracts to each other. What is the conclusion of these experiments or observations or activity? We can say that one same pole of two magnets repel each other and the opposite poles of the two magnets are attract each other. This is the conclusion. We can say that when brought closer to each other, like poles of two magnets repel, but unlike poles attracts each other when brought closer. Mark it. Test for a magnet. You know very well that a magnet attracts magnetic substances and the opposite poles of the other magnets. Now to test if a metallic bar is a magnet or not, do the activity 5 to find out. What we will do? We will do that one to test the whether or not a metallic bar is a magnet. Because we know that one magnetic substance attract by a magnet and the opposite poles of a magnet also attracts by a magnet. So we required an identified metallic bar and a bar magnet. Which one we identify? It is a bar magnet or a magnetic substance. That one and a bar magnet. Keep the unidentified metallic bar or a wooden table on a wooden table. Take a bar magnet and bring one of its poles close to one end of the metallic bar. If the bar is not attracted to the magnet, it means that the bar is made up of non-magnetic material. So it is definitely not a magnet. If it is not attracted by the magnet, that means it is a non-magnetic substance. By non-magnetic substance, we are not making a magnet. So it is confirmed that the metallic bar is not a magnet. If the bar is repelled by a magnet, it is definitely a magnet. Only the same pole of the two magnets repel each other, so it is confirmed that it is a magnet. If the bar attract to the magnet, it may be made of magnetic material or magnet that is its opposite poles facing to the magnet. So it requires further investigation. In that case, if attracts the two substances, parts, then maybe it is a magnetic substance or the opposite poles of the another magnet. Now bring the other pole of the magnet near the same end of the metallic bar. If the bar is again attract of the magnet, it means that metallic bar does not have the magnetic poles. Hence it is not a magnet. It is a magnetic substance. But if it is repelled, then we confirm that the bar which one is in our hand, that is also a magnet, because opposite poles magnets repel to each other. Hence the metallic bar is a magnet. Thus repulsion is the surest test for magnetism. Repulsion is always the surest test of magnetism. Now you see that once the terms related to a bar magnet, the magnetic north pole, the point capital N near the end of a freely suspended bar magnet that points towards the geographic north pole is the earth is called the magnetic north pole. The magnetic south pole, the point capital S near the end of the freely suspended bar magnet that points towards the geographic south pole of the earth is called the magnetic south pole. The magnetic equator, an imaginary line, that is an imaginary line. You see that imaginary line PQ. In your book, the figure is given the PQ, the line PQ. The line PQ, this line is called, this imaginary line bisecting the effective length of the magnet is called the magnetic equator of the magnet. The magnetic axis, see that once, the magnetic axis, this is the lengthwise, that is magnetic equator, and this is the base wise, so it is the magnetic axis. An imaginary line XY passing through the magnetic north pole and magnetic south pole of a bar magnet is called the magnetic axis. So from here we learn fourth definition: magnetic north pole, magnetic south pole, magnetic equator, magnetic axis. So the length or effective length of a magnet is what? The distance between the north pole and south pole of a magnet is called the length or effective length of the magnet. So we learn these things. So today what we learn? We learn the directive property of a magnet. The magnetic pole exists in pairs, attraction and repulsion between magnets, test for a magnet, and some definitions of the magnet. What are that one? Magnetic north pole, magnetic south pole, magnetic equator, magnetic axis, and the effective length of the magnet. Okay, today up to this.